Okay, welcome back. So now we take it up a notch and we actually use that understanding of ratios to work out what was limiting and what's in excess when we've actually been given masses. Right, so the question here on limiting reagents 2, question 1, what mass of calcium hydroxide is formed when 10 grams of calcium oxide reacts with 10 grams of water? So the first step always is to calculate moles. So I'm just going to pause the video while I write that out. Right, so here I've got my moles of calcium oxide is my mass, up here 10, calcium oxide 10, divided by the the formula mass, which is 56, and I know that because calcium on my periodic table is 40 and oxygen is 16. So add those together, you get 56. So that is the N equals M over MR. Okay, come back to that formula there, and then I calculate my moles of water with 10 grams divided by 18. And the numbers I should get are 0.179 mole and 0.556. Okay? So then I look up at my ratio and I know that calcium oxide here, 1 mole reacts with 1 mole to form 1 mole. So what I've got here is 0.179 mole only needs to react with 0.179 mole of water. What I've got though is this, 0.56 mole. So I already know that that one is in excess, and I know that that one is limiting. Okay, so 0.179 mole of calcium oxide is going to react with 0.179 mole of water to form 0.179 mole of calcium hydroxide. So now I've got my number of moles of calcium hydroxide and I've got my formula for it, so I can work out my my formula mass using the periodic table. I can recalculate for mass. Mass equals N times MR. My number of moles, 0.179 times by molar mass of calcium, so that's 140. I've got 2 oxygens, remember, because the 2 outside the bracket means that I've got 2 oxygens. So 140 plus 2 16s plus 2 hydrogens will give me a molar mass of 74, which will give me 13.2 grams of calcium hydroxide. All right, let's just work through the next one together and then you can do the other ones on your own. So what mass of magnesium bromide is formed when 1 gram of magnesium reacts with 5 grams of bromine? Sorry, I moved the camera there. So our ratio, remember here, is 1 to 1 to 1. All right, we've got our masses, so step 1, work out our moles. So our moles of magnesium is 1 gram divided by molar mass of magnesium up here, 24, divided by 24 equals 0.0417, and our moles of bromine is, we've got our mass here, 5 grams, 5.00 divided by bromine up here in the periodic table is 80, but remember it's bromine 2 is our formula mass, so that'll be 160, which gives us our moles of 0.03125. Okay, So we know that one of these is limiting, one of these not. The ratio should be 1:1 to make 1 mole of magnesium bromide. So we look for what the smaller one is, which is a 0.03125. So we know that the bromine is going to be limiting. Our magnesium is in excess. So we're only going to be able to make 0.03125 moles of our product. So let's just say 0.03125 mole of magnesium will react with 0.03125 mole of bromine to make 0.03125 mole of magnesium bromide. Alright, so now the next step, because we're trying to calculate what mass of magnesium bromide is formed, is to take that moles here and turn it into mass using our formula. Mass equals number of moles times molar mass. So number of moles 0.03125. We're going to times that by the molar mass of magnesium bromide. Again, up to our periodic table, remember we've got magnesium at 24 and bromine at 80, but we've got 2 bromines in there, so we add all that together and we'll get to 184, which equals 5.75 grams of magnesium bromide. Okay, now again, I'm available to talk through this now, and you can email with any problems, but try your best to work your way through question 3, and then remember there's a 2-page document. We've got a few more questions there. Okay.